Before you start algebra, there are three core concepts you absolutely must know. These are the top reasons students struggle in class. So these with me in the next few minutes, and I guarantee you'll be ahead of the class from the very first day. Let's get started. First up, PEMDAS and Reverse PEMDAS. Why is this the number one thing to review? Because in algebra, you'll see problems like 5 plus 2 in parenthesis, x minus 4 equals 11. If you don't know PEMDAS, your brain might tell you to do 5 plus 2 first. That's a critical error. PEMDAS or Reverse PEMDAS is the rulebook that tells you what to handle first. Mastering this rulebook is the key to solving almost every type of algebra problem. So, let's dive right in. Let's say we have 2 plus 3 times 4. To solve this question, and all questions with multiple operations, you'll have to use the correct order of operations. This correct order of operations is represented by the acronym PEMDAS. PEMDAS stands for parenthesis, exponent, multiplication, division, addition, subtraction. The order of the letters in PEMDAS tells you what to calculate first, second, and so on. However, note that multiplication and division are considered to be the same level, so they are worked from left to right. For example, let's say we have 2 times 5 divided by 4. Since both multiplication and division are considered on the same level, we'll start solving from left to right. Similarly, addition and subtraction are also on the same level, so they are worked from left to right. For example, if we had 2 minus 5 plus 4. Again, since both addition and subtraction are considered on the same level, we'll start solving from left to right. So, let's get back to our example. Notice from the question that there's both multiplication and addition. Since multiplication comes before addition in PEMDAS, we'll have to do the multiplication first. So, we have 3 times 4, which gives us 12. Next, we have 2 plus 12, which gives us 14. So 14 is our final answer. Let's do another example. Let's say we have 5 plus 2 in parenthesis, 7 minus 4. To solve this question and get the right answer, we must use PEMDAS. Now, from PEMDAS, the parenthesis must come first. This means that we must solve everything inside the parenthesis first before anything else. So, 7 minus 4 is 3. So we have 5 plus 2 times 3. Next, from PEMDAS, the multiplication comes before the addition. So we must deal with the multiplication first. 2 times 3 is 6. So we have 5 plus 6, and if we add them together, we'll get 11 as the final answer. Great. Now that we've mastered using PEMDAS to find the final value of an expression, let's connect it to algebra. Let's take a quick peek into the world of algebra, not to become masters today, but just to see why PEMDAS is your most important tool for what's coming next. This is just a sneak peek. We'll be going through everything step by step in subsequent videos. To do this, let's look at our last example, where we found that 5 plus 2, in parenthesis, 7 minus 4 equals 11. What if we're given the final answer of 11, but are missing a number in the middle? Let's imagine we don't know the number 7. We'll call it x. The problem now looks like this. 5 plus 2, in parenthesis, x minus 4 equals 11. Keep that lucky 7 number in mind. We are going to get it back. Our goal isn't to calculate anymore. Our goal is to be a detective and find the value of x. To do this, we need to get x all by itself on one side of the equation. We have to undo all the operations that are happening to it. If PEMDAS is the rulebook for putting the equation together, we need to use that rulebook in reverse or reverse PEMDAS to take it apart. Reverse PEMDAS simply implies that this time we'll be moving from bottom to top. Reverse PEMDAS is useful when solving algebra problems with a missing number, x. Here, we have to find the missing number x to solve the problem. Now, according to the reverse PEMDAS, addition or subtraction is the first operation. And since we have addition here, we'll start from it. Note that, even though there is subtraction over here, it is within the parenthesis, so it will come in last. To get rid of the addition, we'll perform the opposite operation on both sides of the equation. Opposite of addition is subtraction, so we will subtract 5 from both sides of the equation. The 5 will cancel out. Once we perform the opposite operations, they just cancel out. And 11 minus 5 is 6. So we have 2 times, in parenthesis, x minus 4 equals 6. Next, in the reverse PEMDAS, we have multiplication or division. So, since the 2 here is multiplying the parenthesis, we have to deal with it next. We'll perform the opposite operation. Opposite operation of multiplication is division, so we can divide both sides of the equation by 2. The 2 will cancel out. And 6 divided by 2 is 3. So, we have, in parentheses, x minus 4 equals 3. Now the last operation we have to work on is the parenthesis. Since there's no number or negative outside the parenthesis, we can remove the parenthesis and perform the operation in it. We have the expression as x minus 4. So, to solve for x, we can add 4 to both sides of the equation. Addition is the opposite operation for subtraction. The 4 will cancel out, and 3 plus 4 is 7. So, x is equal to 7. Notice we got our lucky 7 number as expected.
See that reverse PEMDAS trick? It's a key secret most classes won't show you, and algebra is full of them. Don't risk your grade trying to figure it out alone. For our complete Ultimate Algebra course with every step-by-step video and practice quiz you'll need, visit ultimatealgebra.com. Or become an exclusive member on YouTube. Let's guarantee that A.
Next, positive and negative numbers. Here's a secret. Most algebra mistakes aren't algebra at all. They're integer mistakes. Soon your teacher will ask you to simplify 3x minus 8x. The algebra part is knowing you can combine the terms. The part that gets you the points is knowing that 3 minus 8 equals negative 5. If you can't handle the integers, you can't get the right answer. Let's make sure that never happens. Let's learn about addition and subtraction of integers. Now let's look at these examples. Before we solve the examples, there are 2 rules we have to follow. 1. If your 2 numbers have the same sign, add them and keep the sign. 2. If your 2 numbers have different signs, subtract and use the sign of the larger number. Since we know the rules now, let's start with example 1. We have negative 3 minus 4. Note that the middle operation is considered the sign of the second number. So the sign of 3 is negative, and the sign of 4 is also negative. The rule is, if they have the same sign, add and keep the sign. So we add 3 and 4 to get 7, and keep the negative. So the final answer is negative 7. Now, let's work on example 2. We have negative 6 plus 5. Here, we notice that 6 is negative and 5 is positive. They have different signs. The rule is, different signs, subtract and use the sign of the larger number. So we will do 6 minus 5. This is 1. Here, we see that the larger number was 6 and the sign is negative, so we will use that. Final answer is therefore negative 1. Hope you get what's going on so far. Multiplication and division. Multiplication and division are actually easier if you remember your multiplication table. Let's look at these examples. The rules here are, when you multiply or divide 2 numbers with the same sign, the answer is positive. When you multiply or divide 2 numbers with different signs, the answer is negative. Take note, do not confuse this with the rules of addition and subtraction. Now let's work on example 1. We have negative 30 times 2. We will multiply to get -60. The answer is negative because they have different signs. One of our value is negative and the other is positive. Let's work on example 2. We have -60 divided by -3. Here, we will divide to get 20. Notice that our answer is positive because both numbers have the same sign. This is negative and this is also negative. Exponents on negative integers. We're looking at just negative integers because the idea of positive integers is just like whole numbers. So let's look at these examples. Let's first bring in the rules. 1. When you have an even exponent, example 2, 4, 6, on a negative number, your answer is always positive. 2. When you have an odd exponent, example 3, 5, 7, your answer is always negative. Now, we know the rules, so let's work on the examples. Example 1. -5 exponent 2. We said exponents show us how many times a number multiplies itself. So, this is the same as -5 times -5. Since these numbers have the same sign, the final answer will be +25. Now, let's work on example 2. We have -5 exponent 3. This will be -5 times -5 times -5. Working 2 at a time, -5 times -5. This will give us +25. Then we do 25 times -5. Our final answer will now be negative because we multiplied a positive by a negative. Finally, the one everyone dreads. Fractions. Why can't we just ignore them? Because in a few weeks, you'll be finding the slope of a line, which is literally a fraction, change in y, over change in x. You'll also be solving equations like 2/3, all times x equal to 12. If you're comfortable with basic fraction rules, these problems are simple. But if you're not, this is where you'll get stuck. So let's turn this fear into a strength. So, let's start with adding fractions. 1/5 plus 1/2. Now, there are two ways to go about this. You can either use the cross-multiplication method or the lowest common denominator, LCD, method. So let's use the cross-multiplication method. For this method, we first multiply the denominators. So we'll multiply 5 and 2 to get 10. The next step is the cross-multiplying step. We multiply the first numerator by the second denominator. So we multiply the 1 by the 2. This gives us 2. Then we multiply the first denominator by the second numerator. So we multiply the 5 by the 1. This gives us 5. Finally, because it is addition, we add the numerators. 5 plus 2 gives us 7. So our final answer is 7/10. Now let's use the second method, lowest common denominator, LCD, to solve our example. So let's first find the lowest common denominator, LCD, of the two fractions. That is the smallest number that both denominators, 5 and 2, can divide into evenly. So to find this, we check the times tables for 5 and 2 and find the smallest result that appears in both. So, the LCD here is 10. Now, since we have found our LCD, the next step is to rewrite both fractions, so their denominators become the same as the LCD. In other words, we're going to adjust each fraction so that they share the same bottom number as the LCD. So let's start with the first fraction, 1/5. To give it the denominator of 10, we multiply both its numerator and denominator by 2. So the fraction 1/5 becomes 2/10. Next, for the second fraction 1/2. To give it the denominator of 10, we multiply both its numerator and denominator by 5. So the fraction 1/2 becomes 5/10. Note that we are now working with the two fractions, 2/10 and 5/10. Now, since the denominators are the same, let's add the top numbers, or numerators, of the two fractions and keep the bottom number, denominator, as 10. So, 2 plus 5, all divided by 10. This gives us the answer, 7 over 10. Our final answer. Note that this method also applies when you are subtracting fractions. So now you have seen the two methods of adding fractions. Notice how the cross-multiplication method helped you reach the answer faster than the LCD method. This makes it a good choice when you're working under time pressure. You can choose whichever method works best for you, depending on how much time you have and the type of question. Now, let's talk about multiplying fractions. 1 over 2 by 3 over 4. When multiplying fractions, all you have to do is multiply the numerators together. Then you multiply the denominators together. So 1 times 3 is 3, and 2 times 4 is 8. So the answer is 3 over 8. Now let's talk about dividing fractions. Before we learn how to divide fractions, we must learn how to find the reciprocal of a fraction. Finding the reciprocal is easy. For example, let's find the reciprocal of 1 over 2. To find the reciprocal, all you have to do is move the numerator down and take the denominator up. So we are just swapping the positions of the numerator and the denominator. So the numerator, 1, will become the new denominator, and the denominator, 2, will become the new numerator. So the reciprocal of 1 over 2 is 2 over 1. Now let's apply our knowledge of reciprocals to divide fractions. Let's divide 2 over 5 by 1 over 2. To solve this, we'll follow these easy steps. First, we'll keep the fraction that is being divided just as it is. So we'll keep the 2 over 5 just as it is. Next, we'll find the reciprocal of the fraction performing the division. So we'll find the reciprocal of 1 over 2. This will give us 2 over 1. Finally, because we found the reciprocal, the division sign here will change into a multiplication sign. So the question becomes 2 over 5 times 2 over 1. Now we can multiply. 2 times 2 is 4, and 5 times 1 is 5. So 2 over 5 divided by 1 over 2 is 4 over 5. Now we've learned how to add, subtract, multiply, and divide fractions. Each operation follows its own set of steps, and now you know how to use them with confidence and ease.